All right, good afternoon. Uh, First of all, thank you so much all for joining us today. For those who are here the first time, we call this events or session events the waterproofing meetings. This is a event that we've been doing over a year now. Now with a sort of different format, we're trying to maintain those sessions very quick, very brief, but informative as well. So today's topic is going to be focusing about interfaces, membranes, with the main question, does EPDM still an alternative? And we'll cover all or review what Effisus think on that subject today, going deeply on the application, the regulation as well, and what sort of news we intend to bring to the market in the near future. For those who are here the first time, just to let you know, we have a chat and a Q&A comment session. So feel free to leave a question between the presentation. I'll try to answer as brief as possible. If it's something in the middle or by the end of the presentation, we can go over, and I'll also have my details or contact details by the end for more specific queries. So when it comes about EPDMs, we're obviously talking here about interfaces membranes. So it's membranes that usually go around windows, not only on rain screen cladding scheme facade, but coating wall as well. Is a sort of a membrane that everyone is used to, and it's been a long time already in the market. So here you can see in the pictures brief examples of the use or intended use or general application of EPDMs. As I mentioned, most of the times applied around windows of these interfaces, but it could be applied on the coping as well of the facade, interfaces with roofing membranes. So it's a membrane very versatile and has multiple sort of different applications. Important to reference here is that EPDMs or those membranes will work as a seal between all these elements. The intent of use obviously is those interfaces are very vulnerable to the passage of water and air. And this is exactly why we come up or why we choose to applying this sort of membranes. EPDM goes for ethylene propylene dianemometer. As I mentioned, is a material that's vastly applied in the market, I'll say for over 50 years. Main characteristic being a rubber material, so it has very strong capacities in terms of water and air leakage. Obviously, it's important to mention that we need to be very careful when still applying those materials. The main question and it remains why we should or we should not use EPDM. It's obviously fire reaction. So EPDMs are still classified as Class E according to the EN 13501. So it still is a combustible material. So we need to have some careful consideration when still applying EPDMs, especially on coating walling, I'll say, around windows interfaces as well. But by the middle in the end of the presentation, we also have our overview on that aspect as well. Focusing specific on the material. So as I mentioned, this is a material that's been over 15, 60 years already in the market. So since Second World War, is a material that been with such a long time at the market. It's important to mention that we have specific testing data or specific studies that prove its life expectancy. And that brings a really interesting question about this specific materials. Most of the times when we're testing membranes for weatherproofing, we usually go for aging test or acceleration process of trying to determine what are the actual life expectancy of a material. With EPDM, it's something that we have proven past history, materials that have been sometimes completely exposed, I'll say roofing applications, and has not even lose its capacities through the years or very low loss in terms of tensile, tear, water, air, vapor control, air and vapor control as well, when considering all this period of time. So obviously, main function is waterproof. So it's a material that's 100% waterproof. look into the codes, usually tested as CE market as EN 1928 when looking for waterproofing. So it's obviously a material W1, UV resistant, really important, as sometimes it's going to be complete exposure. As I mentioned, in some cases, roofing application, not only in facade, but roofing as well. Elongation capacity as well is something that we need to look or understand when having a real EPDM material. When we say elongation, is being a very flexible, elastic material, and that's really related when expected, especially on facade or interfaces, differential movement on the building. So we need to have this sort of elongation capacity here. APDM, a rubber material as APDM, has elongation capacity up to 400, 500, 600%, depending on the thickness of material, depending on the property itself, but usually around those figures. It's a material that can be applied here in many different sort of temperature and weather conditions. So in our case, if you look for a specific EPDM, it's a material that goes around minus 40 degrees to up to 120 degrees. So very flexible in that way as well, in terms of temperature resistance. Here just to show couple details on the interface specifics, where exactly the EPDM is applied. In this case, on the rain screen project as well. So we need to understand that those elements needs to be completely waterproof, and this material will completely seal those interfaces. So this is exactly the main function. In this example here, we show how we actually detail. Usually we detail a EPDM. In this case, we put a note saying that we should always try to, accommodate sort of a movement, or respecting movements, differential movements of the building. So that's why usually we put this sort of wave here around the application on the interfaces. What we usually see here is a couple of manufacturers or consultants trying to replace EPDM for other membranes to work as these seal interfaces. And I'll tell you why we shouldn't be doing this. So obviously, main aspect here is understand if we do have movements. If we have movements, we need to consider EPDM, because I'll tell you with confidence, there's nothing available in the market that gave us the security or the assurance that EPDM material gave us, first of all, in terms of waterproofing and elongation capacity. Other stuff that we've been seeing a lot is membranes, like a breathable membranes, that it's a very rigid material, has no sort of non-elongation capacity. So that's why we're still recommending EPDMs, especially on those sort of interfaces. And if we go very deeply on the aspects, we need to understand the obviously which consideration which we give, considering that this material is still combustible. If we look here to the standards, obviously, according to the construction product regulation, a material needs to be at least CE market, Now this will probably change or be amended by the next year with UCAS accreditation as well. But for now, we'll need to look at those aspects, and I highlighted here in red those aspects. So first of all, obviously resistance to water passage, water vapor properties, tensile and tear, again, the mechanical properties of the product itself, and trying to understand here this aging as well. So how about this material, how it's going to behave, all these characteristics in terms of tensile, elongation, tear, after a couple of years. The main standards that regulates EPDMs, it's the 13859-2 specific, so that's flexible sheets for waterproofing, definitions and characteristics of underlays or underlays for walls. If we look to the regulation 7, not only EPDMs, but all those points here you see here are considered as excluded for the regulations. So wet apply sealants, tapes, for example, to seal joints and sheeting boards, impregnated foam tapes, we see this a lot, and also any types of sealing that use on bonding or structural glazing application as well. We are very aligned, I'll say, with CWCT and SFE with a document that some of you might be aware. They released September last year. So again, we need to consider trying to reduce the strips of those EPDMs. This document released by CWCT SFE last year, they say we should stick to a limit of 250 wide or width strip of those specific membranes. And that's why we're recommending or we're applying the projects we're involved in the moment. But not only then, we're trying to understand what are the main aspects and how we can actually try to adapt those situations based on the project aspects. To be really fast on this specific, what we're usually doing. Again, trying to stick to a maximum of 250, but covering the PDMs around the windows with our FR solutions that some of you might be aware. So we have externally, obviously, a breather membrane, internally a VCL. And what we're usually doing now at the moment, it's covering or trying to protect as much as possible the combustibility of the PDM with our with a fire rated membrane, in this case, externally applied on the custom silicate board, the sheeting board, a breather membrane, A2, A1 membrane. So this is what we're usually considering at the moment. Again, careful, I had pointed out here, careful with Class B membranes. We understand is a rush in the market to have some sort of a non-combustible or at least Class B membrane to be used in replacement as EPDMs. But I'll tell you, those materials available at the moment do not fulfill the purpose of having a real EPDM. So it's a lack that we have in the market in the moment. And by the end of the presentation, I'll also bring what we're going to bring or what we're studying at the moment to work as a real replacement or a minimum Class B membrane for that purpose. So this is exactly where I was coming from. Here you can just have a briefing idea, highlighted in red, you understand you have the PDMs. And externally, what we did, we cover the whole facade, the full facade, with Effisus Breather FR, which is a A1 membrane. So obviously in terms of reaction to fire, nothing better available in the market. And this is what we study based on lots of data. Okay, this is not one single project experience. We've done lots of testing specific on the membrane, specific considering that we have those interfaces utilizing the PDM, and we have proven that when we have a breather membrane or covering as much as possible the PDM, we protect the combustibility of those seals. Besides just simple, I would say, in plain main applications of EPDM, we can do a lot in terms of customization utilizing EPDMs membranes. It obviously starts with standard rolls. We can add self-adhesive bands, clipping gaskets. We can do corners, full frames, all the way to we call it prefab 3D, which is focused on application where we cover really fast right now. Corners, for those that are side, for those that are sometimes at the design stage, this is really tricky. This is really tricky to have this being done at site. Because obviously the full application here will be compromised if those corners of those specific interfaces are not well sealed. And taking this sort of decision of cutting and gluing, you know, as a cut and patch job at site, it's really complicated for the guys, especially because we don't have very much control environment. The labor, the work that's going to be done, it's not always the same. It's not consistent. So we see sort of a lack when trying to see or deal with the specific details. So this can get really simple as a sort of 90, 45 degrees, as you see here on the top right picture. But it could also get very tricky depending on the shape, depending on the specific form that you have of the windows itself. So what we do here at Effisus, we try to pick up those details at a very early stage, understanding all the project needs. And we do this in a prefabricated way. We produce those corners, specific corners, all made at factory. So once the guy had this inside, all we need is just apply a bit of adhesive to deal with this sort of sealants on that specific case. So taking the same technology, we can not only do corners, we can do a full frame to be applied all around the windows. And again, the job here is pretty much none once we have this at site. Here's just a quick example of a project that it's about to be finalized. This is called the Sways in Paris, a project that we did with a client called Inasus. We have here over 700 windows, and what we come up with as a solution is to developer half a frame, so sort of left and right, the top and bottom, depending the way you see here. We produce this, and as we understand, the middle part, of the windows will vary quite a lot. So the middle part will only be placed as a standard strip of EPDM. What actually gets complicated are the corners itself, and thus we solve producing those half frames. Really fast in terms of application. Obviously, we cannot mention a lot about the quality of the installation, so it's all assured here when we have this all prefabricated. Just quick pictures on the project itself. The next level, and not last, I'll say, because we're constantly improving in terms of application for the specific product. We call it prefab through CO 3D. It's for those exact applications that you see here in the picture. So we usually, and we see a lot, perforations in the facade, like prefabricated steel connectors for the balconies, beams that crossing the facade. This can get different shapes, like an IH beam, and we produce those pieces all at factory with the exactly shape that the guys need. And again, here it's really complicated, limit access, really hard to get this done right. So we're trying to come up with those solutions that predict and help through the installation itself. This other one I always like to highlight, this is also prefab through CO3D. This is we use it as a coordinating walling connection between this facade interfaces. This is a Norman Foster project, and we come up with solution producing this sort of X, and we had another one like a Y shape to deal with this. I would like to highlight here on the bottom, we have very weak spots in terms of application if we have to done this as a standard way. The whole purpose here was to fulfill the full facade with probably 4 or 5 pieces of different typologies, not quantities, but typology of pieces. And again, the whole application or the rest of the interfaces will be applied and sealed as a standard way. But the main part we solved, which were the connections, this intersection part of the facade. What I always like to highlight in this specific example, it's obviously not all projects will require this sort of level of prefabrication, but it's important to know that this is available and we can do this. In terms of process of manufacturing, we have here 2 different technologies. One we call it hot vulcanizing, which is actually like you have a tire or something. We use this technology to bond all these connections, as you see here, which is sort of very strong bonding between all the joints on the pieces. So it's really different. And I'll say in this specific case will be pretty much impossible to have this done correctly as a matter of a standard way on the specific project itself. As I mentioned, in terms of R&D, it's our goal is to obviously to bring by the end of this year to the market a real EPDM fire rated. Class B will be a goal. We have very good indicative tests so far with the membrane that we're developing. And when we say a real fire rated EPDM membranes, that's exactly to fulfill the gap that we find now in the market. We see obviously, and we have fire rated membranes, but they do not fulfill the purpose as replacing as a standard EPDM that we used to. So our membrane, the one that we're developing, should be as a minimum class B. We'll still use this membrane aligned with all this prefabrication process, but very importantly, they will remain the characteristics as 100% waterproof and obviously having elongation capacities, so to allow this movement, differential movement when expected. So this is our goal, and we have very good results. We're moving for testing, probably CE marking on the next couple of months. The results for fire are very good, and we have indicative tests already proving as a class V. We now need to go obviously through all the process on having this material launch, and we hopefully by the end of the year we will have this ready available. So very good, exciting news for this one. So we reached by the end of the presentation. As I mentioned, those sections are really fast, so it's always glad to have all people join us and engaging in those sessions, as they're really fast and we're trying to be very informative in this meantime, 20-30 minutes. Next section will be on the 25th of May, so 2 weeks from now. And that section specifically will be focusing on detailing and consultancy, what we do on our projects and based on our expertise and waterproofing. We also bring a couple case studies and go. This will be very helpful for the architects, the consultants, to see what we do in each project that we're involved and what are the actually, our workflow here, helping this part of detailing process and design process, specifically on waterproofing. So at our website, we can also find more information. We're always trying to post new articles, new documentation there. This is my contact. I also have your Miguel's contact, so technical director. So feel free to send us any inquiries. We'll be more than glad to help you guys. I appreciate for all the attendance. We have here a couple questions, but I'll leave this to probably to an email. Because they're focusing on very specific project needs. I don't think we should be sharing with all. But if we have any other queries, I'll be glad to take this one. Once again, thank you so much.